All right, so the next question would be, how do I choose between different DOE types? Full factorial, fractional factorial, response surface, etc. Would somebody like to come on? Who the person who suggested that?
That's a boil the ocean question, right? You can talk forever about this.
Right, yes, you could, yes. Whoever suggested that, do you have a background for this question, or is this just a general question?
Maybe just comment on what Victor wrote in the chat. Yeah, it definitely depends on where you're coming into this, right? So generally you start screening first, then you can go to higher and higher resolution designs and then end up at a full factorial, but I would certainly never start with a full factorial. It would be a complete waste of your budget.
Classical. I completely agree with what Kevin just said. You don't have to have very many factors in order to get a lot of runs if you want to do all the combinations. And since you can still have the experience or surprises, as we just discussed before, that you are not in the right range, or or you have too much noise, and then go out and do all combinations DOE and find out later that it's really waste of time and money and effort, and also especially if you're new to DOE, it's not the best way to convince your colleagues that this is the best method in the world to do 32 experiments, and then you are only a little bit clever, and then you have to do another 16 to actually learn something. So I would start the other way around. Make a few. There are so many ways that JMP can help you in reducing the numbers compared to a full factorial. And then you can always do more after that when you have found your optimal range or your area of interest.
Thanks, Kim. And Victor, you had your hand up?
Yes, but it was close to the remark from Kevin, and what I mentioned in the chat, that the choice of the design should reflect the objective, meaning at the beginning of a project, you don't know a lot about your system, so you are more into a screening phase where you might have a lot of different potential factors, and you need to screen out what are the most important and active one versus what are the insignificant one. So you start with the screening, and as much as you gather knowledge in the process, you can augment this first screening design into a factorial design to look at interaction and something like that. And then maybe later you can augment it also even more into an optimization design, or even augment in a space filling way to make sure that you are covering the full experimental space of interest. So it's something that should be related to the objective, also to the complexity of the system under study, and that should also reflect the experimental budget, because I don't think someone at the beginning of a project could afford, particularly in a chemical lab, it can be quite difficult to advocate for a full factorial design with 60 runs for chemists. So you have to process it sequentially and start maybe with a small screening design, and then when you progress and when you gather some knowledge, you can go into more details and deep dive into some more specific effect and more complex model. Yeah.
Thanks, Victor.
I think from practical experience, if your factor is higher, it is always better to start with a screening design. Say, from the rule of thumb I have experienced, I think if it's going to be greater than 5 factors, it is better to start with screening, especially fractional or DST-based approaches. And then we can further refine to see if there is any interaction, and then either move on to custom design. That is one. I think I have experienced some good results with that. Anybody can add to this? or refute this point?
Yeah, let me comment on this. It's all about what you know from your process already. Okay, nobody starts with no knowledge going into a process. So you're not all of a sudden faced with a process where you have no clue about what might be an important effect and what not. What I at least saw most often is that that people understand pretty well the main effects, but do have no clue about any interactions or even curvature. So often you come to a good solution if you use known factors. Do I don't know, sometimes a fractional factorial, sometimes depending on the amount of factors you have. A fractional factorial, a full factorial, a response surface designs with just 16 runs, and you know, able to explore interactions and even curvature. But again, this always assumes that you have some knowledge on the process you're working on.
Yeah.
Our first topic looks like the most popular topic here is how do I handle situations where my analysis shows no significant effects or interactions?
Hello. Yeah, maybe just to kick off the discussion, I think the first question maybe to raise would be something like a link between the signal you have measured and the noise of your measurement equipment, because maybe you can be in, let's say, two situations. One where your measurement variation is your measurement uncertainty is okay, but you still have no signal interesting coming from the significant effect or any interaction. So maybe there is something to dive deeper into the range of the factor or the choice of the factors, or maybe the assumed model may not be relevant for the system or something like that. And on the other side, maybe there is something to do with the measurement equipment, and maybe there is simply too much noise in order to catch a signal from this. So expand ranges can also sometimes be a solution, but maybe it could be interesting to first run an analysis on the measurement equipment in order to make sure that what we are trying to measure, identify, and analyze is sufficient for the need and for the experimental setup. And also just a quick note, you don't have to rely solely on statistical analysis, and maybe just trying to graph the effect and the response depending on the different factors and something like that could also help to see if there is some practical significance of factors, even if no statistical significance is detected, but just to see, okay, there is something in my data. Maybe I don't have any runs. I don't have a sufficient amount of runs to really detect a significant effect or a significant interaction, but maybe just plotting the data first could help see if some factors, some main effect or some interaction effect could be relevant for the system.
I think I can add a point here, Victor. I think adding a center point may alter the situation because it might add curvature to the effect, or adding all the terms, making a simple data check on whether all the terms are added might also bring some sort of a effect. So I think the first step would to basically expand the factor ranges and explore if everything is accounted for. I think that would be the first logical step, as Victor correctly noted. Anybody can add to this from your experience?
Yeah, I can definitely second
ahead,
what Yeah, thanks. I can definitely second what Victor said there about checking your signal to noise, and what Chandra said about expanding the range of your factors. I've often had it that the initial range was not chosen to be wide enough, so you're basically not seeing any significant change, while there practically would be one if you made your range wider. Another one that's a little bit more basic, but this has caught me up a couple of times, is I've just messed up the import of my data. So I have misaligned the target value that I'm measuring with my factors. I, for example, shifted everything by one row. And then, of course, yeah, it's not going to show any effect. So it's a bit of a stupid thing, and it's a fun thing to try yourself. Take any previous DOE you've run where there have been significant effects, randomize the order of the output variable, and you should see that you get no significant effects, as it should be, right? So then it's just, it points out a human error, which you can quickly pick up, as Victor mentioned, by plotting your data.
Thanks, Alan. Sorry, Kevin. Thanks, Kevin. Go ahead, Alan.
Are we still on factor ranges?
Yes.
Yeah. I think my something I heard, which I thought was useful, was I'm a chemist, and something that's worth bearing in mind is trying to keep your ranges within physically relevant limits, whether that's so being aware of things like solubility, melting points, and boiling points, so that you try to stick within a one sort of system where there's a sort of limited number of phases present, and to try to sort of stick to a range, or try to stick to a range where there's a single mechanism operating, such that if you were to change the underlying mechanism of what's going on, there's going to be a big discontinuity in your results, and that will sort of, I guess, show up in your results. So it's just being sort of cognizant of maybe the physical limits of the system.
Thanks, Alan. Uwe, go ahead.
Yes. Actually, adding center points or replicates is certainly helping identify the quality of the DOE that has been run. That's for sure. What also can happen is that the experiment is missing what is called a noise variable, a nuisance factor, that is somehow impacting the experiment. I had this once with very simple impact of temperature and humidity that made some of the effects not really visible. So in considering this with a covariate analysis, basically could help them to understand the effects that we were expecting.
Yeah, I think I can add to what you were saying. I think it's a jump-centric approach. You can also use contour plots or interaction plots or profilers before even jumping into the actual DOE. We can try to do a graphical analysis of the data to see if they are even statistically significant, or if you are in the right, experimentation path. I think contour plots or even constructing a profiler would help, and see what kind of interaction they might bring. Have you experienced it before? Any additional thoughts on this?
Okay, and you had an email question about making use of the box transformation option. Do you want to expound on that?
Yes, I'm glad you brought that up. I wasn't able really to use the button on this web page, so I sent to Maria an email. Yeah. Actually, when analyzing a DOE, there is this nice box Cox feature, very nifty tool, I have to say. And so the question is basically, what is the best practice on how to use that? What I learned from a free factor experiment is that one factor is basically better handled by doing a log transform. Okay. Actually, when analyzing the experiment, I have included that, run the model, looked what the effects were, found curvature, found main effects, found interactions in there, and then I removed the insignificant terms and used the box-Cox transformation tool as this was adjusting to give better, a better fit. So the point is, do I use this after removing the terms, or do I, use the box-Cox with a full model without having to reduce this? Does anybody understand what I'm saying, or was that too confusing?
Go ahead, Victor.
Yeah, sorry, I don't want to speak all the time, but
Okay.
what you have to know on your system, it's not a matter of model refinement and doing the transformation before and after, because I think this, let's say, transformation part, if it's needed, no matter the effect in your model, you will need this transformation. Maybe the question will be a bit different with the box-Cox transformation, but in any way, if your response is very not normal or very strange, the transformation will be needed anyway. What you have to take care is it relevant to do the transformation of the response, no matter the method, with the log normal or with the box-Cox transformation or anything, or should you use a general regression model in order to have not a transformation, but to have a function for the variance and a function for the mean response? Because most of the time I see people confuse the use of transformation in general and the use of general regression model. And it's completely different to model, for example, the log of a response versus the response of the log, I mean, for the log average versus the average of the log, for example. So it's completely different, and it's more a question on should you use a transformation because the residual show you that you don't respect the assumption of linear models, and you have no way to make this assumption correct by removing or adding new terms, or should you use a transformation because there is no other way you could you could respect the assumption? I hope it's more clear.
Cannot use the transform of the analysis, the residuals that look skewed, and doing a log transformation basically helps improving the model significantly. There's one other thing, perhaps, what JMP is suggesting when using this nifty box-Cox feature is suggesting a factor, say a 0.15 or something like this. What is your experience? Would you use the suggested number, or would you round this to the next number? In this case, is 0, which stands for a log transformation, to apply this?
Go ahead, Kim.
Yeah, I think you cannot choose like any number. There's these fixed numbers, and they, like you say, a 0 is a log transformation, and another one is a square root or square or something. So there's a kind of a discrete list, or maybe you can make some kind of any decimal number, then it would be a very complicated transformation, I think. So as far as I remember, you get a kind of you get a graph that is like a parabola, I think, that will show you where the best point is, and that is an optimization that, and then you should use the one closest to that. But I don't think, from my memory at least, that you can choose any number. So you would choose the one closest to what the parabola lowest point suggests.
Yes. Okay. Okay, good. Thanks.
Should we move to the next one? David. David had proposed a question earlier about what to do when you lose a run of DOE. I think there's been chats with this. Do you want to come on screen, David, or do you think you've got your answer?
Yeah, sure. Sorry,
Thanks,
because
David.
I didn't know how to ask the question on the website, so when I saw the opportunity, I just took it. My concern, and I guess this happening to everyone working on experimental sciences, is that you have a low budget, so you try to make as few runs as possible while getting the most information, which means that the loss of one reactor one run is highly, it's a huge issue. And I've been talking with some colleagues here, and they have some ideas, and I just wanted to know from people who have experienced the same issue before, what to do. Victor mentioned a lot of nice ideas. Actually, I was rereading them. But mainly, my issue is I have, for instance, a definitive screening design. So it's a design that's used for screening, in which I try to, the advantage is that with few runs, you get a lot of information because of how the design is made. However, it depends on your entire runs being completed. Otherwise, it can lead to non-significance in some of the parameters. I had this issue. Experimentally, we lost one run. And I was wondering if I have to add an additional run, how many triplicates would I have to get on the control to compare? How do I do with the blocking? Do I set the blocking as a random effect? And then add it, create one block for the previous run, then one new block, this single run that was done afterwards, and then do a new model. Like how should I do it on Jam? That was my question, and I haven't finished reading all the nice suggestions. So if anyone wants to step up and just explain that would be wonderful. If not, I will just give it a try.
Go ahead, Victor. Go ahead, Victor.
Just a question for you, David. So you mentioned you use the DSD and you have one missing run. When creating your DSD, did you use the minimum number of runs, or did you use some extra runs, just for my understanding?
I used the minimum number of runs because
Okay.
the idea was to lower the budget as much as possible.
Okay. So indeed, it might be a bit tricky in this case, because you won't have a lot of degree of freedom to fit a model. Anyway, you won't be able to fit a full response surface model, so it's not the point. But it might be a little more difficult. But the good part is that you have a lot of different platforms to create a model, even in the absence of a run. Maybe just first try to graph where is the missing point compared to your experimental space, because if it's let's say in a border or in a corner of the space, maybe there is something to do with constraint. Maybe this is something that is not doable or very complex.
No, it was just a mistake in that sense.
Okay.
So it could have been any runs. Yeah.
Okay.
That's why, I mean, that's a good thing, right? That means that the experimental design was good enough to get a response for everything. It's just that something happened on the equipment and one of them was lost. So,
Okay.
yeah.
So maybe, yes, you could use several platforms like the fit to level screening. I'm not sure it is, I think it works for DSD, but I have to check again. You also have the fit definitive screening design. Maybe it works even if in the presence of missing value. This is something to check. And you could also perhaps try other modeling methods like stepwise or generalized regression, where you could have slightly different models, and you can check if in the absence of these points, the model are in accordance with each other, or if you have strongly different models. And this could lead to an intuition about the importance of this point or not. And if you are able to run this point again, maybe use the model you have created before to validate them, to see if...
It's just, I mean, I think that's a really good idea. However, my number of runs is small enough that I don't have enough degrees of freedom to get any conclusions. So I need to add something somehow. So my question is, can I take, for instance, another experiments because I'm doing some definitive screening from some parameters, and then I'm assessing some of the same parameters in an OFAT, for instance. So I have runs on running a different time point. Can I just get them inside and then select the blocking and do 2 blocks and have it as a random? How would you do that in a definitive screening? Because I'm not sure you have the blocking option. Like, I mean, you can always add it, but I'm not sure it goes with the ADA itself. So yeah, it's like the issue is not having enough degrees of freedom on the current design, how to add more degrees of freedom. And I think that could happen in any model, right? If you do an RSM and you are too low on runs, you might hit the same wall of not having enough runs, like enough degrees of freedom. Yes, so Phil is quite negative right now, saying that it will not work. That's my question. On the chat, I can read that he said that it will not work with missing runs. So can you add some runs so you don't have any missing? And if so, how? That's kind of my main concern. And would it make sense statistically, of course?
Yeah, I'll just maybe remind myself and everybody that if you do an experiment, it is a valid data point. If it's very close to what you did already, you will not gain a lot of new information. But and it was not completely clear to me why you could not later repeat the one you were missing. Let's say your equipment is working now. Can you just do what you planned already? Or?
Yeah, that's actually my question. Would it make sense statistically, or should you split that as a different block? Because of course the results are not coming from the same plate, the same operator, the same day as all the previous ones. So I'm afraid that there might be some blocking effect in that sense. Because
blocking is when you know or have some suspicion that it will actually matter if you do it the same day or the other day, or and that depends, of course, on your situation. But in general, I would try and do what all the different tools in Jump will help you with is to try and spread out your designs in order to get as much sense after you did the runs, so they are not in one corner or only in the middle or whatever. That is, and it follows very strict algorithms in how to optimize it, but still you can always do like sometimes when I do screening designs, the software will tell me to put this factor at 1.666667. I won't do that. I will put it at 2 or 1.7 or whatever. But that doesn't mean that this run is completely invalid. It's just because when you calculate it very accurately, statistically, it should be at 1.666666.
Yeah. I completely understand this. For me, the issue is this lack of degrees of freedom, that then the model tells you cannot fit anything. You need at least one. Like you need one more run than the parameters you are trying to test. Otherwise, you will not.
And that's what. And then you could say you could basically do duplicate one that you did already. But why would you do that? I guess it's the same effort if you do the one you already planned, but that somehow did not work, or you repeat one. The number of freedom, degrees of freedom, is basically tied to your number of runs. Then you need another run.
Yeah, and that's my question. Let's assume that blocking might happen, because that's something that it's really difficult, at least from my point of view, to statistically say, no, whatever I run tomorrow will be exactly the same as I run right now. Like for me, what the outcome of a definitive screening will give you some tolerance intervals, for instance, you will have ranges. And I'm afraid of just taking a run done in a different, a different technician, in a different plate on the equipment, by a different day, a different batch of whatever raw materials, and claim, okay, this is exactly the same. I would feel more comfortable maybe getting it as a blocking, but I might be wrong. That's what I'm trying to see. What are your thoughts on that?
To me, I'm not so used to using blocking, but it sounds a little bit artificial to have, I don't know, 10, 20 runs in one block and then one in a new block, it's like I'm not sure you will gain a lot from that.
Okay, so let me give maybe a bit of context on why I'm a bit afraid. We have a robot, right? And the robot going to run the experiment. And whatever you prepare, the robot can run 24 reactors at once or 24 samples at once. What I'm doing now is I'm adding a new set and I'm running, for instance, this additional one that I'm missing. And I'm afraid that, for instance, all the vessels are coming from a different box, therefore the different manufacturing date. And that could lead to challenges, or maybe not. And if so, because I was wondering, could I just run this missing reactor or missing condition with 3 center points and then group these 3 groups, then generate a block and put it on the definitive screening with these 2 blocks? Would that be an overkill? Would it be better, just as you said, and Kim, as Kevin actually supported you and Phil as well, just run whatever is missing, put it inside, and the experimental noise should actually be similar enough. But how can I explain that to someone or justify myself? I don't think I can just go with, I have a hunch that this is not impacting my result. I need a way to make everyone kind of stay on page with me and agree.
Yeah, I think that it's always a good idea to in your logbook to put all details, and because they may turn out to be nuisance factors, as one of the other participants mentioned before, even if you don't think so. And then you can do this run charts where you can see something is changing a lot just because now is another date or now is another batch of raw materials or something. And then you can at least get a feeling for how much does it matter. I think it really depends on what type of experiments you're doing. Sometimes it doesn't matter at all, and other times it will matter a lot. And then you can say, I would claim that then you are also up for a hard challenge to do any kind of mass production based on this later, because then you have variations that you need to know more about, like in raw materials or stuff like that.
Yeah. No, I agree. But I see that the challenge, I mean, it's kind of the same in a way that there's no straightforward answer. And I may be replying to CK on the chat. The reason why I wanted to run the center points is because it's a successful run and I could do triplicates and get some values out of it. If I repeat a successful run, which could be any of the other ones, I would only have one value to compare against one value. And I don't know, I mean, it would be different for me to assess, for instance, the variance of this new set of runs, because it would have only one value to compare. And if I do center points with more than 2, I could actually get some standard deviation, for instance, on my analysis. That's why I was thinking about center points. But yeah, I mean, I'm just trying to see. I completely agree with you, Kim, in that sense that there might point a lot of issues if you cannot just trust and add an additional run. It's just that I need a way to convince everyone. And I think the easiest is with numbers. And that's why I was thinking if there's anything that maybe, for instance, I could add the block and then the block itself would tell me through JAM that it's not a significant effect. Therefore, you can remove the block. It's just for me, the blocking, because I work in some other designs where we saw a lot of blocking effect on different equipments. And our goal was always to have blocking as a random effect and see, does it make sense? And if not, then remove the blocking. So our by default option was always to have blocking on and then remove it. And that's kind of my question. If you have to have blocking on, how many runs would you do? Would you do the center points? Would you do successfully repeated runs plus the one that failed? Would 3 be enough, for instance, or yeah? And can you just feed that into the definitive screening? So yeah, there's a lot of information in the chat. I will read it afterwards. But yeah, well, yeah, thank you for your input. It's it's very nice to have some people with different backgrounds and scopes tackle the same problems.
What is the purpose of center points is another question, if someone would want to take a crack at this.
It's about detecting curvature, if there is, or it may also serve the purpose of understanding experimental error. So even if you're adding a center point and you're not getting indication for curvature, it helps, understanding experimental error if you have an unreplicated design.
Okay, here's another one, determining appropriate factor ranges. Go ahead, Bill. Hey, Bill.
I think this might be newer for everybody. I don't know if everybody's played with the design space profiler in the profiler platform, but if you're looking to define your ranges, if you've run a DOE and you've already done the modeling, definitely check out that design space profiler. It will help you find the optimal ranges for at least, I think it's up to 15 factors right now. So I know folks are asking for more, but it's a very powerful tool.
Great.
I do have a final question, if that's all right.
Yeah, go ahead,
Okay.
Johan.
All right. Let's assume I have a set of data that have been measured in the lab, but that hasn't been following any design of experiment principles. So we have duplicates, we have things all over the place. Basically no design of experiment principles. How would I propose new runs to augment that design? Because as I can see, they've used mostly one factor at a time. So I understand that I would want to try runs which are able to highlight interaction effects. What would be your aim or your way of adding new runs in order to have the more information possible? I've heard also of Bayesian optimization, which is more looking towards a specific goal or specific value. How would that come into place? I don't know whether that makes sense. Yeah, I saw the Augment Design platform, Victor, but I wanted to know whether there was something specific in that part of JMP, which you would.
I think regarding your topic, it might be one of the best option at end, because with OFAT data, you won't be able to have interaction effect or curvature effect or something like that.
Mm-hmm.
So in order to not say to the people, okay, we start from scratch and we don't care about your data, which is not something you would try to do in a political way, let's say, then you can say, okay, great, you have some data. What I can propose is that we augment your initial set of data and we try to build a relevant model thanks to what you have done and what we will do together. So I think this is why I would recommend to use the Augment Design platform, because on a political and statistical, scientific point of view, you will be able to get something from the data, and with a minimum amount of effort, because you won't start from scratch again.
Yeah.
You mentioned Bayesian optimization, but I'm not sure if it's very relevant for your use case, because as you already have some OFAT data, Bayesian optimization might be, let's say, a little bit biased by this way of collecting the data. So even if it may propose some points that could be, let's say, similar to interaction effect or something like that, I fear that the convergence needed to get to the optimal points may be quite slow or long to obtain to get to this optimum. So that's why augmenting your initial set of data into a DOE might be the best option, because you will be able to create a model based on this, or at least you have several ways to analyze the data, and you can make it very graphical to the people, and you have no blind spot in your experimental area, which can be the case with Bayesian optimization.
Yeah, right. Okay. And so if I have, let's say, 180 input variables, I have quite a big amount of runs, but I assume I should reduce that amount of variables. Well, since it didn't follow any screening design principles, is the data that I have at hand enough for me to be able to reduce that amount of variable, or should I simply try to augment the data set that I have with all of the input features that are in the data set? Because that seems quite a lot to me.
Yes, what you have to see in your data is if it's really OFAT or if there are some variation, meaning, for example, if they have tried to modify one factor, are all of the others fixed, or do you have some factors that have changed also with the first one that have been modified? Because if everything else is fixed, there will be little information that you could get from the data, no matter the number of points. So I fear that if you try to reduce the factors with this set of data, you might be misled by some significance you will be able to see, but that are not relevant because it will be in a very, let's say, narrow experimental space for each of the factors, and it will not be linked or connected with each others.
Yeah.
So
I
maybe
already carried out
yeah.
analysis on trying to see what's the standard deviation over the mean, just to see what kind of variability I have for each of those columns. And for some of them, I don't have any variability, so I assume I wouldn't be able to measure any effect. I mean, highlight any statistically significant effect from this. But for all ones, yeah, it seems like OFAT most of the time. Sometimes they have changed one of the other processing variables, but yeah, usually it's more like they've tried. It's like recipes, so they have tried different kind of ingredients. Sometimes they put it in it, and sometimes they don't put it. So that's why the number of variables is quite big. The amount of variables is quite big. Right.
Kim?
Well,
Kim, you had a comment?
Yeah, I think I just noted, Johan, that you said you don't see a lot of variation, but that is actually not the same that this factor is not important. It just shows that you did not vary it through the OFAT that it could be very important actually. So,
but if I don't have,
it's hard. Sorry.
Yeah, I understand. But if I don't have much variation in my data set, how can I, statistically prove that it is important, that factor? I should have more runs, right?
Yeah, but you should introduce more variation. That was DOE is all about. Introducing variation purposely in an organized way. So I would be careful to say, okay, this one, our output did not change at all because, and also this factor was never changed, but that's not the same as it would not affect your result actually, if it was changed.
Okay. Thank you for making that clear. At least I won't